Hello, this is assignment number 7, and assignment number 7 is on chapter 6. Chapter 6 is about work and energy. And the essence of chapter 6, I'm going to summarize it here very shortly. First of all is the definition of work. Work is defined by the work done by a constant force is defined as the product of the force times the displacement times the cosine of the angle between the direction of the displacement and the direction of the force. So if the force is parallel to the displacement, then the angle is 0, and then the work is simply the product of the force times the displacement. If the angle is 90 degrees, then the work is 0. And if the angle is 180 degrees when they are anti-parallel, then the work is certainly negative and is given by minus F times this. Via Newton's law, when we now calculate the work done by the net force, then we arrive at a different formulation of Newton's law, which is summarized in the work energy theorem, that it says that the work done by the net force is equal to the change in the kinetic energy of the object. And the kinetic energy is defined as 1.5 the mass times the velocity square as before. In addition to this, the forces can be divided in two groups in which they can be conservative forces or non-conservative forces. And the work that are done by conservative forces is always the change in the potential energy. This is done for the springs and for gravity. In the case of gravity, the change in potential energy, it has to do with the change in the height. And in the case of the springs, the change in potential energy, it has to do with the change in the extension or compression of the spring. The work done by non-conservative forces in general, here you have friction forces and normal forces and all kinds of forces. So if we go to now through the problems. So let me just call this equation 1 and this is your equation 2, and let's just say that this could be our set 3 of equations. This is a standard problem in which you have to apply equation 1. In problem number 2, you are pushing a box horizontally. So when you're pushing the box horizontally, you have this force F, but there is also a force of friction that opposes the force F, and there are the common other two forces. So the distance is given to you, and also the value of this force is given to you, and the value of this force is given to you. So the only thing that you have to calculate is the total work, which is the sum of the work done by F plus the work done by the friction force, and you have to be careful with the signs. When you have number 3, on number 3, you have a frictionless surface, and the only force acting is this constant horizontal force, and the work done by that force is the change in kinetic energy of the object. So now we go to equation number 2. There. And because the kinetic energy is 1.5 mv squared from the final kinetic energy, you can get the speed. And because it started from rest, the change in kinetic energy is just 1.5 mv squared, where this is the final speed. In number 4, this is a way in which you can save energy. For example, if you remove paint from a plane, so you remove a layer of paint, and since the mass of this paint is given, certainly the energy that you save is the potential energy that this mass will have at that height, and that will be mgh. The energy that you save by taking this mass to a certain speed is the change in kinetic energy of that mass. So since the mass is given and the speed is given, you can calculate this quantity. So it should be pretty straightforward. Now we go to a problem in which we have an inclined plane, and we did this quite detail also in lecture. So if you have an inclined plane with 30 degrees and you have a mass that is going down and there is no friction, then the distance here is given. This distance to you is given. So if this starts from rest, what's the speed here? Where the speed here, the kinetic energy here, is equal to the change in potential energy here. So if you start with an mgh, you are going to end up with that down there. If this is h, and from the geometry you are supposed to calculate this. Now if there is friction, part B is a little bit more involved now, because when there is friction, the work done by friction, which is a non-conservative force, is going to be equal to the change in kinetic energy plus the change in potential energy plus the change in kinetic energy. So you are going to find a different speed here because the potential energy is still changed by this amount, but now you have to take it into account the work done by friction in that process.